Hello, I'm Matthew Caren from Palo Alto, California, and today I'll be presenting TRoco, a generative songwriting algorithm using jazz music theory. So first I'll be talking a little bit about the inspiration behind the algorithm and what specifically I'm focusing on. Then I'll move on to a brief overview of jazz theory, talk a little bit about the structure and function of the algorithm, short demonstration, and then talk a little bit about next steps. So at its most basic, music is storytelling. It's about communicating a narrative arc. Just the idea that there's some moment or character event in which there's some issue or problem that's then resolved. And in this kind of narrative arc, the idea of tension and release is key. This idea that there's some problem or something that needs to be resolved and then showing how this plays out. And TRoco, the name TRoco itself, is based on this concept of tension and release. It's a tension and release oriented composer that's driven by a user's input of a tension and release contour over time. So a little bit about the prior work in this area. There are many generative algorithms based on machine learning, based on classical music. Bob Keller did a lot of amazing work in machine learning based on jazz music. And there's also a lot of different ways of interacting with an algorithm, how to input in the desired content. We have the valence arousal plane, we have things like scariness. And for the generation of music itself, we have, as mentioned before, machine learning, but we also have algorithms based on music theory. There are a lot of algorithms based on classical music theory, and even a fair number of tension and release-driven algorithms based on classical theory. But TRoco focuses on something somewhat less explored, which is tension and release algorithms driven by jazz theory. So now a little bit about why specifically jazz theory. And at this point, I think it's important to note that, as stated by Mark Levine in his book, that there's no one single all-inclusive jazz theory, however that there's a common thread of development in jazz theory, and that this thread has evolved logically from the earliest days of jazz. Now, as with a lot of things, there's no correct answer, there's no one valid answer, but there's this main body of ideas and concepts, and this idea can be generalized and abstracted to analyze a lot of musical structures. And furthermore, one state doesn't really restrict the choices for the next state, and the choices of states in general are very much not restricted. I also think it's important to note that the basic jazz theory framework can be used to analyze and create in a lot of current popular music styles. So the jazz theory used in TRoco is based on the work of Mark Harrison and Mark Levine, and kind of the approach to jazz theory taught at the Dick Grove School of Music, which was a jazz school that used to be in California. Mark Harrison, the author of two important jazz theory books, also applied this framework to pop music, R&B music, country, rock, and a lot of different styles. So the first implementation of TRoco works specifically with chords, and in jazz theory, chords are abstracted into roots and qualities. So for instance, here we have the C dominant ninth chord, which is split into a root and a quality, and together we get a C9 chord, which is the notes C, E, G, B flat, and D. So a chord quality, which in this case is a ninth chord, determines the notes of the chord relative to the root, which in this case is a C. And this is really powerful because it enables the analysis of musical structures rather than notes, because, for instance, a dominant ninth chord functions in similar ways regardless of the root. So we can abstract chord functions rather than looking at the notes themselves. And this is also how a jazz musician might be taught to approach chords. So the driving force behind TRoco is this idea of tension and release, this feeling of tension, of a rising stress that's leading up to something wanting to be resolved, and the subsequent release of this tension, the resolution, relaxation, and feeling of completeness of the tension that came before it. In the algorithm, this is encapsulated by a tension and release quotient, or TRQ. It is what the user inputs into TRoco to drive generation and drives all composition decisions inside the algorithm. It's a value between -10 and 10, with -10 being the most released and 10 being the most tense, that drives the desired tension of the next choice. It's the tension of release imparted by a change. It's also important to note that this is not an absolute value, it's a relative value. So for instance, if one chord movement imparts a TRQ of -5 and the next movement results in a TRQ of -2, it's still getting more released, even though the amount of release is less than the previous change. And to calculate the TRQ, there are two basic considerations. There's vertical tension, which depends on elements only observable at the present moment, and horizontal tension, which depends on elements that are present in different moments. So I'm going to start with vertical tension, and I'm going to play an example that has increasing degrees of vertical tension over time. So a couple of the considerations that we use in TRoco to analyze vertical tension that can be seen, some of which that can be seen in this example, are chord quality, which also factors into chromaticism within a chord, for instance, through extensions and alterations. So for instance, in that last chord, which is a C7 sharp 5, the sharp fifth would be an alteration that makes it more tense. We have the root being in or out of the key, and also chord tones being in or out of the key. And now it's also important, I think, to consider that tense isn't necessarily negative. Tension release is not a negative positive scale. It's this feeling of leading towards something, this idea that you're anticipating something to be either resolved or not resolved in the future. Now I'm going to move on to horizontal tension. So I have another example. And some of the considerations for horizontal tension in TRoco are the root note interval, that is the root note of the current chord compared to the root note of the last chord, notes that are in common with the previous chord, and notes that are half step away from the previous chord, or leading tones, and then also the chord quality of the previous chord in relation to the current chord. And this last point manifests itself a lot in jazz music as parallel movement, in which one chord quality is constant while moving around the root, creating tension. So we can see that, for instance, the last chord is a B major chord. This is the same chord quality as the first chord, which is a C major chord, but because of the context, it's heard as much more tense than the C major chord at the beginning of the sequence. So just stepping through a few examples of how the TRQ might be calculated for a few chord movements, we have C major to A minor in this example. It's a diatonic movement. The root note interval is a major sixth. All root note intervals are ascending, just for simplicity's sake. And A minor shares in common two chord tones with C major. So it's not a drastic change. It's a fairly mild root note change, and we end up with the mildly released TRQ of -2. But now in this example, if we change that A minor to an A7 flat 5, we still have that same root note interval of a major sixth, but now our chord is a dominant chord with a chromatic alteration of the flat 5. And we also have two chord tones that are not in the key of C major, namely the major third of C sharp and the flat 5 of E flat. And we get the more tense TRQ of 4. So with the general idea of the TRQ established, we move on to the structure of the algorithm itself. So the user inputs in a TRQ over time. For instance, this might be if we wish to get slightly more tense to very released, we might have a TRQ contour of 1, 3, 10, -10. And also, before generation starts, we define a domain of possible root notes and possible chord qualities. And at each step, at each TRQ value, we choose the best fit for the TRQ, the chord with the TRQ closest to the contour that the user inputted. And after iterating through all the chords, we have a chord sequence. And at the bottom of this very rough pseudocode for the general structure of the algorithm, we have the calculation of the TRQ, and we have all these different considerations from the vertical and horizontal tension of a movement. And it's important to note here that there's by no means a right answer in how to calculate the TRQ. The TRQ represents this idea that with any given change, there is a certain amount of tension or release imparted. So a different composer, a different improviser, a different listener might have a different idea of how to weight the different considerations in the calculation of the TRQ. So in the future, a user might want to control these different considerations of how things are weighted in the calculation of the TRQ, and different weightings of the considerations of the TRQ would result in stylistically different generations. The controllable parameters could also be extended in the domain of possible chord roots and chord qualities, which would also change the stylistic content of the algorithm's generations. So TRoco was used to generate musical accompaniment for a very simple game-like implementation where the player has control over a character in a 3D environment, and as the character navigates a path through this environment, they pass a skull, which represents conflict or tension, and they pass the skull towards the treasure chest, which represents victory or release. And the TRQ, the goal contour, is calculated based on the relative distance from both objects. The closer the player is to the skull, the higher, the more tense the TRQ is, and the closer they are to the treasure chest, the lower the TRQ is. So before I play the video, I just want to walk through a few notes about the actual generation in the video. On the chart on the right, we have the target TRQ, which comes from the player's distances from the skull and the treasure chest. We see that in the middle it gets much more tense, and then towards the end we release. The domain of chord choices was defined to be the C major scale as the roots, and the chord qualities to be major 6th, major 7th, we have minor 7th, minor 9, and minor major 7th chords. And the TRQs calculated based on the player's distances from the skull and the treasure chest were fed into TRoco as the target TRQ, and TRoco's chord output was simply passed to an arpeggiator, which triggered samples that can be heard in the game. So we can see that generally the chords become more dissonant as the TRQ goes up. We also have very odd root note movements, such as the F minor major 7 to the A7 when the TRQ reaches 10. And then at the very end of the generation, we have the very common 2-5-1 progression, which is extremely common in jazz music to end a phrase or section. So here's the video. So some possible next steps for TRoco. First of all, analyzing composers within the TRQ framework to inform the design of TRoco. As mentioned before, the weighting and the calculation of the TRQ of a movement can greatly change the stylistic content of TRoco's generations. Different composers, different improvisers might have different ways of imparting tension or releasing it, and the way this is implemented inside the TRQ can result in stylistically different generations. Also in the future, we're planning on applying the TRQ and the general TRoco format to melody generation, in which not only would the tension or release of chords and melody separately need to be calculated, but also considered would be the tension or release created by the coexistence of chord and melody. Also in the future, plan to test possible implementations of TRoco in game environments, but also using something like sentiment analysis that could be used to create a musical accompaniment for a text feed or a social media feed, or even a soundtrack for something like an audiobook. Thank you.